Hey guys, welcome to another edition of Math Academy. Let's talk about what we're going to learn, why we're learning this, and how you will know if you have successfully learned everything you need to learn. Alright, so what are we learning? Students, that's you guys, will be able to write and use the formula to find volume of a cone. So we've already looked at volume of a cylinder. That was with Mr. Schrog yesterday. Now we're going to volume of a cone before our quiz tomorrow. So next it says, why are we learning this? We have already explored volume of cylinders. Now we will continue our use of the volume formulas. How will you know if you successfully learned? So when you're given a cone, if you can apply the formula that we create and solve for the volume of a figure, you will have successfully met every expectation you needed for today. So let's go ahead and get started. Before we get into the book, we're going to do a little bit of review. So I want you to get your Cornell notes out. So I'm going to give you a second to get those out if you don't already have them out. Okay, now that your notes are out, we're going to look specifically at cones and what we wrote down for cones. So if you're partner number 1, as it says up here, you're going to be reading the definition we wrote. Partner number 2, you're going to explain what we wrote in the example box. So 1s have the definition that we filled in our blanks. 2s are explaining what we wrote in our example box. Ready, go. Okay, so now that you've had a chance to hopefully kind of brush up on what a cone is, let's look at it one more time together. So on the left, when we get to an underlined word, you guys are going to help me out, and everyone's going to read it. So a cone is a object with a or base. So again, here's a cone. This is what we're going to be looking at today. The important thing we talked about in the example is that height is always measured straight up and down, not on the diagonal. So sometimes they're going to try and trick you and tell you this measurement diagonally. We're not falling for it. We know the height is just straight up and down. Okay, R again is the radius. The last thing we're going to talk about before we get into our book is the difference between radius and diameter. We covered this a little bit yesterday with Mr. Schrog, and now we're going to look at it one more time. So this time we're going to switch, and partner number 2, you're going to read the definition. Partner number 1, you're going to explain our example box. Okay, ready, go. All right, so if you could finish up your discussion and look up here one more time, let's discuss radius and diameter. So again, when I get to an underlined word, you guys are helping me out. So radius is the distance from the base to any place along the, and it's, so again, it has to be the very center of the base, going across to our outside, and it's like halfway. So the radius is halfway. Let's talk about diameter. Again, you guys help me out. It says the distance from one of the base to the other edge, and it is. So it's all the way across, but it does have to go through that center point again, just like the radius. So radius is halfway, diameter all the way across. All right, so we're going to go to page M5-105, and at the top it says our definition for a cone, which we've already talked about a little bit. It says a cone is a 3D object with a circular oval base and one vertex. One vertex means it has one point right here at the end. So it comes to a point right here and here. Okay. Number 4 says identify the radius, diameter, and height of each cone. So we did this yesterday with Mr. Schrog and cylinders. We just talked about it in our Cornell notes. I want to give you about 30 seconds here. I want you just to draw in the radius, draw in the diameter, and label these, and draw in the height. Remember, height is always straight up and down, not the diagonal. So I'm going to give you a second. Go ahead and do that. Now that you've had some chance to work, I want to go ahead and partner share this. Partner number 1, you're going to share A. So where'd you put the radius, diameter, and height, and why you pick that. So make sure you're explaining. Partner number 2, you're doing B. Again, explain where and why the radius, diameter, and height. Ready, go. Okay, the next thing I need for you to do is skip over to M5-104. So I'm going to give you just a second to skip over M5-104. So M5-104 at the top says problem solving with cones. Obviously, we talked about today we're going to be finding the volume and we're going to be problem solving with cones. This is activity 2-3. Again, we're on page M5-104. So it says use what you know about the volume of a cone to solve each problem. So we're going to be talking about volume of cones here. We'll talk about the formula. We'll get to that and how to solve these. So on question 1, it gives us some information that's going to really build this entire page. So we're going to read this together. Again, when I stop, everybody reads the next word. Okay, so if you're wondering if that means you, it means you, everybody. Here we go. So, following along. Joel owns a yogurt and smoothie shop. He just placed an for cones and the contains 3 different sizes of He wants to, one more time, say that word again, of each cup to help him determine how much to for each. All right, so again, we've got Joel. He owns this frozen yogurt shop. He's ordered 3 different types of cones. They're obviously a little bit different sizes. You can look at them and see. We have different heights for each of them, and we have different measurements. Now, we got to be smart here. If they give us all the way across, remember, that's not the radius. What is it called if it's all the way across? One more time, everybody. All the way across is the, okay? Halfway is the, and again, all the way across is the, okay, so we'll talk about how we're going to use that here in just a minute. So if you look below that at A and B, so A tells us to predict, everybody say predict, which cone has the greatest volume, and explain your reasoning. Now remember, volume is what fits inside of these cones. So you're going to just take a prediction, an estimate, and I want this in a complete sentence, of which cone you think could fit the most frozen yogurt, so which has the biggest volume, and explain your reasoning. So why do you think that? So I'm going to give you about 30 seconds to jot down a sentence explaining which one you think in your prediction would hold the most yogurt. Ready? Go. So now that you've made your explanation or your prediction, I want you to go ahead and share this with your table partner. Partner number 2 is going to go first. Ready? Go. So chances are that you and your partner might have come up with a different prediction for which cone you think it is. Some people might have said, ooh, cone 2 is the tallest cone, so maybe that could hold the most. Or maybe cone 3 because it's the widest, it has the biggest diameter. Or maybe cone 1 because it's kind of a mix of both, it's in between. So we're going to actually figure this out and see. So B says to calculate the volume of each cone. So let's go through that. Now before we actually do this work, I want you to watch how this is going to happen. So let's pretend this cone isn't in your book, but let's pretend we had this cone here. We have a cone that has a height of 12 yards, so it's a really big cone, and a radius of 5 yards. And let's talk about how we're going to figure out this volume. So the formula for volume of a cone is 1/3 pi r squared times the height. So somewhere in your book, write this volume formula down. So it's 1/3 pi r squared times the height. Okay, so what this really is saying is 1/3 times pi times 5, because that's our radius squared, times 12, because that's our height. This is all multiplication. So even though they're stacked next to each other, this is all multiplication here. It's just filling in a formula like we did with Mr. Schrag yesterday. When you type this into the calculator, though, we want to use parentheses instead of the multiplication sign. So each term, or each section that we have, needs parentheses. So volume equals parentheses 1/3 times pi in parentheses times 5 squared. Notice that the squared is inside my parentheses, not on the outside, times 12. So we're just subbing things in like we have practiced before. And what this ends up is I end up with the volume equals 314 and 1600ths yards cubed. Now let's talk about our label. Since this is a 3-dimensional figure and we're finding volume, our label is always going to be something cubed. So yards cubed, feet cubed, inches cubed, whatever. Okay? So again, here's our formula. We're just substituting in what the radius is and the height. Now we got to be smart. Again, like in cylinders, if they give us the diameter and we want half of that for the radius, we're going to have to do some division. You're going to have to divide by 2. So be careful with what they give you on these 3. So here's what you're going to do on page 104. Now that you've seen an example, you're going to go ahead and you're going to do B, calculating the volume of each cone. So I'm going to give you a couple minutes here. Go ahead and calculate the volume. Okay, so our work time is over. Hopefully we had a chance to get through all 3. If you are partner 1, you're going to discuss cone 1. You're going to talk about where you plugged in your information, what your formula looked like, and what you got for your answer with a label. If you're partner 2, you're doing cone 2. Again, where did you put your information? What did you get for your answer? What's our label? And then I want both of you to look at each other's answer for 3 and compare and see if you agree. Okay, so I'm going to give you about another minute. Go ahead and share your work explaining everything. Ready, go. So let's check our work and see how we did. So here's what our formulas and our answer should have looked like. For cone 1, we should have substituted in The radius, now again, they gave you diameter on cone 1, so you had to divide that amount in half, so be careful here. Make sure you did that. Then we multiply by our height, and we get 4 1400 inches cubed. Let's look at cone 2. They gave us the radius and the height, so we were just putting it in its place. Then we have 19 3600 inches cubed. Finally, for cone 3, we again had the diameter, so we had to cut that in half, split it in half to get the radius, 1 3/4, multiply that by the height, which was 6, and get our answer of 9 8200 inches cubed. If you don't have a label, we need to make sure we fix that, okay? Now, what I want you to think about is, think about your prediction you made up above, and just turn to your partner and tell them if you were correct. So you're going to say, I was correct because, or I was incorrect because. We're going to take like 30 seconds and discuss what we thought versus what ended up happening. Okay, ready, go. So as you can see, what actually happened was cone 2, our tallest cone, had by far the biggest volume, the largest amount of volume. Okay, let's look down to the next part. So if we go to C, again, we're going to read this together. When I stop, everyone helping me out, read the next word, so please follow along. So it says, if Joel's market reveals that he should $3.75 for the cone, what prices would you propose for the other two? And you're going to explain your reasoning here. Okay, so what it's saying again is that the smallest cone, so let's look up here. Was cone 1, cone 2, or cone 3 the smallest, everybody? One more time, which cone was the smallest? Well, we can see cone 1 was the smallest. So he's saying cone 1, the smallest, is $3.75. So based on the volumes that we have, we're trying to make an estimate of how much he should charge for cones 2 and 3 so that it would be fair. Okay? So here's how I want you to set this up. You're going to have cone 1, and we already know cone 1 is $3.75. You're going to take an estimate or figure out what you think cone 2 should charge, cone 3 should charge. Now this is important. It says explain your reasoning. So I want to see a sentence or something explaining why that is. Okay, so I'm going to give you about 45 seconds to a minute. Go ahead and come up with your estimates. All right, so if you're partner number 2, you're going to go ahead and you're going to share what you thought for cone 2, what your prediction for how much you should charge would be. If you're partner number 1, you're doing cone number 3, and you need to explain your reasoning. Make sure you have an explanation. All right, go ahead and share. So let's see how we did. So I'm going to show you what I came up with. So here's what I came up with. So I noticed that cone 2 was about 3.5 times as big as cone 1. And I just took that by the whole number 4. So 4 times 3 was 16. So it's about 3.5 of those, maybe a little bit more. So I just multiplied $3.75 times 3.5, because it's about 3.5 times, and I got $13.13. Now, depending on what you came up with to multiply by or what you estimated, you could have a different number, but our answer needs to be close to $13, $14, $15 for that cone. Okay, let's go over to cone 3. I noticed that cone 3 was about 2.5 times as big as cone 1. So again, if cone 1 was about 4, cone 3 was almost 10. That's 2.5 times, so I multiplied that and got $9.38 for cone 3. So again, you don't have to have the exact same answer as I do, but it should be pretty close. It needs to be about that. So if we think about this, the biggest cone should charge the most. The second biggest cone should be the second most expensive, followed by our cheapest cone, which was $3.75. Okay, so we've got some practice now. Now I want you to go to M5105, and you're going to go ahead and calculate the volume for each cone. It says to round your answer to the nearest hundredths. If necessary, we're going to go ahead and do that. That's 2 decimal places. Okay, so I'm going to give you a few minutes. Go ahead and work these 4 problems out. Go. All right, so hopefully you had a chance to get these done. If you're partner 1, I want you to talk about A and B. So you're just going to explain what you did and how you got your answer. Partner 2 is going to be C and D. So go ahead and explain your work for those as well. Okay, ready, begin. All right, so let's check our answers and see how we did. So I'm going to give you a moment. You can look up here. I have my answers for number 3, A, B, C, and D. And here are the correct answers we should have gotten. Now, we'll say that 3C is missing a label. You want to make sure you have your label of meters cubed. So make sure you have that label on there. Everything else was just centimeters cubed. All right, so let's go down to question number 4. So this one's a little bit different. Again, you're going to help me out and read the next word when I stop. So 4 says, use the, one more time, we need everybody, use the, for the volume of A, to solve for each unknown dimension. One more time, say dimension. Okay, so instead of giving us all the information and we have to find the volume, they're going to give us the volume, as you can see. They've given us the volume, and then we have to figure out everything else. So if we look at A, they've given us the volume, 3,042 centimeters cubed. They've given us the diameter, which remember is all the way across, so that's 25 2/10 centimeters. And then we're trying to figure out what the height is of this cone. So we kind of have to work backwards a little bit. So the first thing we're going to do, and you're going to do this with me, is we're just going to remind ourselves of the formula. So go ahead and take a second and write the formula out like I have it here. All right, so we see our formula. The next thing we're doing is we're going to plug some information in. So again, where V is for volume, we're going to write what our volume is. Pi is still pi no matter what. Still 1/3 is still 1/3. Now we need the radius, but they gave us the diameter. So real quick, turn to your partner and explain to them if they give you the diameter, how do you get the radius? Go. So hopefully you said divide by 2. So we're going to have to divide this by 2 in order to get the radius. We're going to square that. And then again, they want us to figure out the height. So height's going to be missing. So as we fill this in, let's look at what we have. So this turns into 3,042, because that's our volume, equals 1/3 times pi. Those things don't change. When we divide our diameter in half, we get 12 6/10 as our radius. We square that. And then height is missing, so we're going to just have h. Okay. From there, we're just solving this like it were equations. So let's think. On our right side, there are some things we can combine. So we can combine 1/3. Pi, remember, is a number, so we can combine that. And we can combine that with 12 6/10 squared. The only thing we can't combine on the right side is h, because that's just a variable. So I went ahead and I combined these. So I'm going to give you a second to jot this down. So when I combine all of my constants on the right side, I get 166 3/10, and I went ahead and rounded to the tenths place. But I still have h here, but think of this as an equation. We're down to essentially the last step. 3,042 equals 166 3/10 h. Now we know from what we talked about up here, this is multiplication. So everybody help me out. What is the inverse of multiplying? One more time, what's the inverse of multiplying? So our last step would be to divide both sides by our coefficient over here on the right side, which is 166 3/10, which leaves us with 18 3/10 centimeters for h. Now you might be wondering why this isn't cubed, because all of our other answers have been cubed. Remember, all this is the height, h. So h is never cubed. H is just a value. When we measure things, it's just a value. So what this is saying is that the height of the cone is 18 3 centimeters tall. All right, so here's some time for you to work. So you're going to come up here to question 2. Do question 2 on page M5105. Make sure if it says to explain your reasoning that you're explaining your reasoning. Then you're going to come down here to 4. We did A together. You're going to do B. So this will be your work time to finish up class. Good job today.